All right, lesson 4.6, we're gonna learn 3 new ways to determine if triangles are congruent. Each of these are less involved than the other ones. We're not gonna deep dive into these three as much as we did the other 2. We're gonna hit them kind of quick and we're gonna keep going. So the first one is angle, side, angle. All right, so here we look, I've already labeled and filled in things, but what I want you to focus on is the visual. I've got 2 angles with a line in between. We got a side in between. I call this like a dumbbell, right? If you think about in a weight room, right? You have a big bar with like the 2 weights on either side of it. That's what this is. I have a bar in the middle with 2 weights on either side. If I have that matching on both, then I have angle, side, angle. That's the image that we're gonna look for. So in this picture, I've got a couple givens. And it tells me SQ bisects some stuff. So up here, SQ is doing some cutting in half. It cuts in half RQT, which means that, come on, I have to just delete it, rewrite it. Means that this is going to match that, and it also tells you it's bisecting RST, which is that matching this. Okay. So I have 2 angles here. I'm going to have the definition of bisect twice. And then I want you to remember and carry over that if 2 triangles share a side, that is always going to be important. That right there, that side is important. QS is congruent to QS. That's what we just labeled, and that's reflexive. So what I have here is I have a bar with a green and a red. And up here on this top triangle, I have a bar with a green and a red at either end. That is the dumbbell. That is angle, side, angle. Here I have lots of parallel lines, which means I'm probably going to have lots of angle relationships. But I guess let's get the givens first. Just one. Okay, it's the only thing. Oh no, there's 2. Oh man, they put it in both the same box. I thought I had 2. That's a bummer. Okay, let's figure it out though. I'm gonna have JK, that's this one here, is parallel to LN. That one there. All right, and let's see. Let's pause there. Let's pause there. I have a line that goes to both triangles. I have this one right here that connects to both. That's going to be important, and that's what they've written here. KL is LK. It's not exactly the same, so it's not reflecting like a mirror. It's swapping, so it's symmetric. Okay. So, I mean, I know, right? We're in the angle side angle part of the notes. So that's what we're looking for. Maybe that will help us build this. I know that if I have that dumbbell in the middle, then the things in the corner, the angles in the corner here, this one, it's gonna need to match that over there. So let's see, what 2 angles did I just mark? JKL is the left one. JKL, and that matches MLK. So I knew that needed to be there. The parallel angles let me do that because, the parallel lines give me alternate interior angles. Like 4 out of 5 times with parallel lines, you're gonna use alternate interior. The one time that left over is gonna be corresponding like we did before. So if you see parallel, you should probably be thinking alternate interior. Let's see, it also tells me that JLK, I can label this one JLK, that one is gonna match, well, this one. It's the only one that makes sense. And yeah, that's again, alternate interior. They're inside the parallel lines, and one's on the bottom, one's on the top. And then we already had that dumbbell, where I had the bar in the middle, and then it's a red bar, blue, red bar, blue. Last one here for this one. Fill in your own, okay, angle, BAC. C is congruent to angle DEC, reason given. C is midpoint of A, E, given. Thing that I'm trying to prove, triangle A, B, C is congruent. I almost drew outside of the box. Angle, no, it's triangle EDC. I'm recording like 3 hours at this point. I'm going on, so I'm getting a little loopy. The fatigue is setting in. But what I do love, that word midpoint, love to see it, because we're gonna have the definition of midpoint right here. Love it when they give me the freebie. Okay, so let's label the picture and then I'll get to the midpoint thing. It says angle BAC. That's this right here, BAC, that one. It matches DEC, that one. Okay. Now it's the midpoint thing. C is the midpoint. C is in the middle of AE. So that means this piece here matches that piece there. So my statement for definition of midpoint is going to be that AC is congruent to CE. All right. And yes, we are in the angle side angle portion. We know that we should be looking for this. It's not cheating to know that you're supposed to be finding that. The question is, if this is supposed to be a dumbbell, right, with the bar in the middle and an angle over here, the only other angle connected to that dumbbell is going to be that one. Over here, angle, side, angle. It's the only one that makes sense. Is there a reason that I can say those green angles are congruent to each other? And the angle is yes. Have you gotten the tattoo yet? Those things are vertical. So what do I write? I can't say angle C is congruent to angle C, because am I talking about this C, that C, that C, this half of the C, the whole thing being C? There's too much going on. So I need to label with 3 letters. The left one is angle B, C, A. And that is congruent to the right one being angle D, C, E. All right, next one. Angle, side, angle. Okay, so this one might be tricky. This one can be definitely tricky. Angle, angle, side. I don't know what I said before. Angle, angle, side. Now, remember the first one that flowed, right? We had SAS. It was side, angle, side. It flowed. I went from one side to an angle to a side. This one needs to flow too. It needs to go angle to angle and ends on a side. It needs to go that way. So right here I have this. I start at an angle. I go to another angle. I don't have a side in the middle. And then I end on the side. Angle to side. Okay. That's what we need to have. Angle, angle, side. This one is hard to see. I will give you that. All right, fill in your own. I got YZ bisects. Angle WYX, that's a given piece of information. The other thing, angle YWZ is congruent to angle YXZ. And the thing I'm trying to prove, WYZ is congruent to triangle XYZ. Oh, that was given. Oh. Almost left a free point on the table. What am I doing, man? Okay, well, I see the word bisect, so I'm going to use the definition of bisect, just like I use definition of midpoint. The question is, what am I going to put here? I'll figure that out in a second. Let's label the picture first. YZ, this thing, is cutting WYX in half. So that means that this thing is going to match that thing. So that's going to be my statement for definition of bisect. It's going to be that angle, the left one, WYZ, is congruent angle X, Y, Z. Okay, awesome. That takes care of this piece of information. Now I need to label this one Y, W, Z, Y, W, Z. It's that guy there. And it's gonna match this one here. Okay, I've labeled that. All right, well, I see that I have two triangles and they share a side. That's pretty important, okay? This right here, the fact that it shares that side is important. So my statement is gonna be YZ is congruent to YZ, and the answer is reflexive. Okay. Now we know that we're in the angle side portion of this, right? We could have put that answer at the beginning. But look at this, okay? We flow from the green angle, to angle, the red angle, and we end at the side. Angle, side. Here, angle to side. Okay, it's important that we see that. It's important that because this is gonna get tricky. Okay, two more quick. Fill in your givens, lots of them. Okay, excellent. I see the word midpoint, so I'm just gonna go ahead and write definition of midpoint. And now all of the free stuff is done. Of the 12 boxes here, I filled in how many of them? 4, 8. That's 2/3 of the way done for free. All right, label the picture. ABC. This corner, or this angle, is gonna match CED, that angle. I'm gonna have some parallel lines. Okay, I'll get to that in a second. Parallel lines are probably looking at alternate interior or maybe corresponding. But C is the midpoint of AD. So I'm gonna say, for my definition of midpoint, AC is congruent to CD. Okay. Now let's look at the parallel line thing, because I never actually labeled that. I have AB being parallel to CE. Okay. All right. Well, there's only one option here. If I know, and I do, that this is going to be angle side, that means I need to be able to flow from angle to side. So I only have two choices. Either I'm going to use this angle, and it's going to match that one, or I'm going to use this one, and it's going to match that one. The second plan is a terrible plan, because there's no, like, the perpendicular line doesn't touch this angle over here. The perpendicular line touches this angle right there, and it also touches that one there. So now I can see that I have angle to side. Okay, so that works. That's gonna be my thing. I'm gonna say that angle BAC is congruent to the other angle ECD. So now the question is why? Why does that work? They're corresponding. They're in the same position. They're in the exact same spot. Corresponding angle. Sometimes you can puzzle solve and you can be like, this is the piece of information I know I need, and then go back and figure out, okay, but why, right? It's all about figuring how you can do this the best. All right, we have two more? We have two more. Oh my goodness gracious. PR bisects angle QRS. PSR is congruent to angle PQR. These given. This down here, PSR, congruent to triangle PQR. All right, I see the word bisect, and I see a line that they share that's going to be important. But let's start labeling. PR is this line. What is it cutting in half? QRS. So that means this piece is going to match that piece. I've labeled this information. And actually, because bisect, I'm going to use definition of bisect. And my statement here is going to be just what I drew there, that angle SRP is congruent to angle QRP. I'm going to continue to label my picture. It tells me that PSR, that one, is going to match PQR, that one. And then in this triangle, I see that there is an overlapping side. That's going to be important, always is. So PR is congruent to PR. That reason is going to be reflexive. That's my default statement. If you want to do symmetric and swap it out, you go for it. I just like reflexive. Now I see that I have angle, angle, side, angle, angle, side. Last one. All right, I got midpoint. That's exciting. LG parallel to JM. H is midpoint of LM. LGH, congruent, that's a terrible H. MJH. I see midpoint, can use definition midpoint. I don't know what my statement is yet, but I know that's gonna happen. Okay, I got parallel lines. Let's label that. LG is parallel to this one over here. And now H is the midpoint of LM. So that is going to match that, and that's my statement. LH is congruent to HM. Definition of midpoint. Okay. So I've got a side. And I know that I'm trying to make angle, angle, side work. Well, only two angles are touching my parallel lines. This angle here. And this angle up here. If it's gonna be angle, angle, side, those are the only two possible choices that work. So now I need to find, well, this one, I'm not gonna just jump and say that this one's congruent to that one, because there's no basis for that. The transversal that this green one is on connects to this corner here. And the transversal that this red one is on connects to that corner there. So here's my statement. I'll say that the green corners are congruent to each other. I can say that angle L is congruent to angle M. I can use one letter here because there's only one L and one M. And the reason is alternate interior. My second statement is going to be that angle G is congruent to angle J for the exact same reason. Right there, alternate interior angles. On to our last one. Hypotenuse, leg. All right, so this one doesn't care about angles so much. It just needs you to have a hypotenuse and a leg. Well, the hypotenuse is always the part of the triangle, the side of the triangle that is across from the box. So here I have my 90-degree corner. The side that that's facing, that is always the hypotenuse. Always, always, always. over here, I just have a leg. Okay? If you're not a hypotenuse of a triangle, you're just a leg. This is a leg, that's a leg, doesn't matter. Okay? Legs are interchangeable. But the hypotenuse is a very clear part of the triangle. It is always across from the 90, or also, it is also the longest side of a triangle. Okay? This time it just happens to be a 90 degree, so that works out. Let's take a look. We got some right triangles. So label my picture. They're right triangles, LMP, and so, okay, so that one, I got a box there. I'm gonna have a box here. That's what I'm counting as labeling for that piece of information. Now, this piece of information that it gives me, ML, is congruent to MN. Okay. That's where I'm labeling that. And then it says MP is congruent to MP. Well, that's the part that they share. That's the thing in the middle. The reason for that is reflexive. So if I look at this now, I have two sides that are congruent. The hypotenuse of the triangle, the side that is opposite of the box for both of them, that side matches that side because they each have one tick mark. And then I see this leg that they both share. So my reason, I have hypotenuse leg. Okay, fill in your own. Triangle WVX. No, I'm gonna run out of space here. Okay. Triangle WVX and triangle YZX are right triangles. Shorthanded. Given. WV is congruent to YZ. It just says given. Okay. I don't know what that means or how that's important, but it's given. And then, ooh, it gives me another piece. X is the midpoint. Midpoint of WY. Okay. Excellent. Given. I see the word midpoint. I'm going to use definition of midpoint. That hasn't changed. It will never change. It will always be there. The question is what I'm going to write for my statement, though, and I'll figure that out in a second. It says that these things are right triangles. So I'll put a box there, and I'll put a box there. And that's that piece labeled. WV matches this one. And now X is the midpoint of WY. So this piece matches that piece. That's my statement, that WX is congruent to XY. And it looks like I forgot to put the thing that I'm trying to prove at the bottom. It's almost like I've done about 40 of these today. Triangle. WVX is congruent to triangle YZX. The reason? All right, the reason. I have a hypotenuse of both that match. And then I have this green leg that match. Hypotenuse, leg. I think that's it.